Welcome to Deepcut Surrey, a place of my favorite pub, the Frog. And we also have an amazing new development of beautiful houses behind me. I always admire them. I think they look absolutely stunning.
But we're not here for the pub today or to admire this lovely architecture. We're here today on a heat pump rescue mission because one of these poor residents has had a pretty bad install from a supposedly experienced heat pump installer.
And by the end of this video, you will understand why so many heat pumps fail on new builds, what to look out for if you are having a heat pump installed or buying a house with one, and most importantly, what to do with an underperforming system. Hi, Roman. Thank you for inviting me and Adam to your house.
Thanks for coming. And the reason why I invited you is we bought this house 2 years ago. Again, it's a great house, but what I heard about the heat pump efficiency, I don't see it in my house. So I'm wondering what can we do about it. So that's why I'm here.
Tell us more about the house. How big is it? How many bedrooms?
Sure. So it's roughly 190 square meters and 5 bedrooms. The underfloor heating on the ground floor and radiators on the first floor.
And you've got quite a high spec. Those houses are not your usual spec houses, are they?
Yeah, this is I think it's kind of a pilot project for the developer. They bring some Scandinavian technology, very well insulated. We have an MVHR, and it's technically, I think it's the specs of the passive house. So it means there is a very low heat loss.
What is MVHR?
MVHR is mechanical ventilation with heat recovery. So it's pretty much the air blows through the heat exchanger in the attic, and it's kind of the hot air from the house heats the cold air which is sucked from the outside. So in this case, instead of opening your window for ventilation, you're pretty much losing 10%, 15% of heat instead of 100% when you're opening the windows.
Yeah, so with every home, obviously we have the fabric losses, the heat that just leads through the wall or windows, and then ventilation losses. And typically you have to allow for people to obviously open windows when they're showering or cooking. Otherwise you end up with mold, especially in a house like this that's so hermetically sealed. MVHR is the perfect solution here. You couldn't actually build this house without MVHR. It would literally rot from the inside out unless you had the windows open, which undoes the point of doing the insulation in the first place.
I want to ask viewers to go to the comment section and give us their prediction of what the heat loss of this house is. 5-bedroom, fully detached, high spec, new build with almost 200 square meters of floor area over 2 floors. So guys, please leave your prediction of the heat loss in the comment sections now. I also want Roman to tell us what he thinks. He's lived in this house for over a year now. Yeah. I want you to take a pen and paper, write down what you think the heat loss is. I've already done my heat loss. I took the liberty of doing it off the plans that you sent me before this meeting. And Adam's gonna show us some really, really exciting technology on his iPad. What is that, Adam? What do you have there?
One of the main problems of putting in heat pumps is the amount of time and effort it takes to do heat losses and size radiators, etc. So we've made some software using LiDAR technology, which is essentially LiDAR technology scans the room and creates the house in a 3D digital model. And we've joined that with the SIBSI way of calculating heat loss. And generates heat loss. I should be able to do this house, I'm guessing, in 20 minutes, but we'll see how I get on because I don't use this every day. And yeah, it just makes the whole sort of process a lot quicker. And at the end, gives us the opportunity to see what flow temperatures work best and what flow temperatures should run at. So it'd be good to compare the original design with what we think might be more accurate.
Well, we'll get viewers, we'll have my calculations, we'll have your calculations. Roman is an engineer himself. So he'll have a pretty decent idea what the heat loss might be, and then we're going to reveal it later. To the main topic.
Yeah.
What is wrong with your heat pump? When did you notice something was wrong? What are the problems?
Yeah, so I notice it when I start looking at how much it consumes, and I start comparing it against what I can find on forums, which I was expecting about COP of 3.5-ish as a good benchmark. So it wasn't that. Let's put it this way. It was way lower.
Much poorer.
Yeah, exactly.
If you didn't look at scope or COP or efficiency, if you never looked at it, would you have noticed there was a problem?
It was weird because it was turning on, turning off, like
you've not
cycling. Yeah, and I know it's not good for. It's almost like if you have a car, you don't drive it like 100 miles and then 120 to go on the average speed of like 60 or something, right?
I think as an engineer, that's like clear to us, you know, we know the cycling's bad, but for an average homeowner with, you know, low heat loss, I don't know if they'd notice that. And this is the shame, and I think this is why some installation companies have got away with poor installs. Yeah. And continued that pattern of, oh, well, I haven't had any complaints in the past, therefore I'll just keep doing that in every property I go into. And it's only thanks to homeowners that have a little bit of an eye for detail, have looked in the system, know what SCOP is, and highlighted.
What is SCOP and COP? Because some people might not understand it, because maybe we should explain it, because you just use this terminology, and what are we talking about?
SCOP, seasonal coefficient of performance, versus COP, which is coefficient of performance, is the ratio of heat output from the heat pump to the amount of electricity put in. For example, a seasonal coefficient of performance, or SCOP, of 3 would mean that you bought 1 unit of electricity and that generated 3 units of heat. And COP, which is a moment in time rather than the average throughout the year, you'd kind of look for expected anywhere between 1.5 to 7, really, for any one moment in time, but averaged over the year. 3.5 would kind of be the minimum benchmark for us.
That's a benchmark right now, yeah?
As the minimum.
Yeah.
I'd say we like design for that as our minimum, and really we're targeting, I'd say average for, well, I know average for ours, for Heat Geeks, is 4.44 currently, is our average SCOP.
So we know the system has been designed by a well-established company. We know who they are, right? We know it's been installed by a well-established renewables company.
Yeah.
We would expect more from those guys, right?
Yeah, and part of the problem, I think, is there are too many cooks in the kitchen. And like one company designed underfloor heating, one company designed like remaining of the heating. There is another company who like supplied the kit, and another company who installed. And it's almost like if you want like a jacket, you would rather like order it from one person, not like from 5 different people. And they would say to you, my part is great, but like I just want to make sure that someone is responsible for the jacket. So
Yeah, shared responsibility here, right? We had that conversation with Adam, and Adam, has a theory about experience and quality of installation.
The number one indicator of if you have a good installer or not, for me, and this isn't a blanket approach for everyone, is their experience level. Generally, the more experienced they are, the less likely they are to be good. Now, that's a very controversial statement, but the bad habits that have been developed over the years and the potential lack of complaints have meant that people and processes have been put in place which are comodulant, so they don't change or adapt. Whereas we're finding, and especially in the groups that we sort of interact with, the newer entrants into heat pumps, not necessarily heating or plumbing and heating, but into heat pumps specifically, they're taking the sort of care and attention to do it right the first time round, and not having to unlearn bad habits like unnecessarily put in buffers, which is what you'll see from any unit 5 to 10 years old and previous. Normally always has a buffer, and normally always zoned as well. We now know that that's not a panacea by any means. I truly believe experience is not an indicator at all, or a lot of experience is a very poor indicator of quality. You made a very good point though. Also, these newer sort of more well insulated homes are actually much easier to get more efficiency on. Actually, you need you don't need the top experienced engineer to put these systems in. You can have, not any engineer, but it's an easy one to achieve, which is contrary to what you might think. You might think, I'm putting in triple glazing, I should get the top engineer in on this home. You don't necessarily need it, although it can go wrong. Where the skill is needed is for retrofitting older homes. And that's where these engineers need to be going, but that's why we need to hold the whole industry more accountable and raise these standards, exactly as you said. So that's a really good point.
So I think it's about time we had a look at that plant room of yours, see how it's been installed, and maybe have a look at the unit outside as well.
yeah, absolutely.
So we've got here, what size is it? 11.2 kilowatt Mitsubishi Ecodan.
Oh, wow.
Sunk into the ground a bit, so I don't know if there's any footings, but
I think that's probably fine. I think that actually looks neater than typically. You know, they site them really high above the ground. I think that's fine personally. It's actually been put in quite well. It's just that this unit is absolutely ginormous. Right. Okay. So first of all, I've noticed that they've got the pipe size correct accidentally, because they've assumed this needs 11 kilowatt heat pump. They should be using 28 mil pipe work, possibly even bigger. They've used 22 millimeter pipe work. They bought 28 to the room, then reduced down, which would be incorrect had they have got their heat loss right. So well done, you've accidentally got it correct. Second of all, so this is the flow pipe coming down here. The first item we come to on the flow pipe is an expansion vessel. Expansion vessels belong on the return pipe at the lowest system pressure, not the high system pressure. This creates a negative system hydrostatic pressure in the system, which can draw in air through a process called diffusion. So that's our first mistake. Actually, our first mistake was the minute we came into the room with the pipe work, reducing the pipe size. Second mistake was expansion vessel on the flow. Filters are great. Not so much plastic ones, so we try and advise not to install plastic filters. Again, diffusion, air, and they can go brittle over time with higher temperature systems. But this is on the flow, so it's protecting his radiators from any junk that the heat pump might produce, which is the wrong way around. You want to protect your heat pump from any dirt that your system might produce. So what they've installed here at this point is a hydraulic separation. You might term this as a low loss header or a hydraulic brake. And typically you would put this in because you need a pump, a meaty pump to pump around your big 5-bedroom house to get all that energy around your radiators. We don't need to put in this hydraulic brake. And then additional pumps to go around the radiators and underfloor. And putting in this hydraulic brake essentially means that you have to run your heat pump outside even hotter than you would previously have to, because there's some mixing and blending in the flow temperatures which reduces the flow temperature out to your emitters. So in here we have an 8 actuator underfloor heating manifold with 4 thermostats for 1 open loop area. So if you wanted to have one half of your kitchen diner one temperature and the other a different temperature, you could have them at different temperatures. In reality, that's physically impossible. It's a complete waste of labour, controls, manufacturing. It's just literally pointless. This is an open plan ground floor. It should all be the same temperature. It should all be off one thermostat, if a thermostat at all. So, and when this was originally installed, it also had a blending valve and pump as well. The issue we've had in the UK is that underfloor heating manufacturers produced a solution for all heat source types, for boilers, high temperature systems, low temperature systems, and they come with this high temperature protection kit to stop too high temperature getting into the rest of the system. That's lowering efficiency for low temperature systems because we're already producing a low temperature system. We don't need to blend that down more, so it's lots of extra things that were installed just needlessly. Thankfully, since the customer's been here, they've had that removed. That's one step in the right direction, but there's clearly much more to do here.
now, Roman, what did you write on that piece of paper?
Okay, it is 5.5 kilowatts.
Have you?
Yep.
You've got 5.5 kilowatts. Yeah, that's correct. I've got it here. I've calculated this at 3.6 kilowatts.
Wow.
So I've got average of 20 watts per meter. My air changes are 0.25 because I took MVHR into account and I've used U values for new build 2021. Are you lower than 3.6?
I think you're potentially 20% out.
Okay.
But which way?
Which way? Well, let's find out.
I've got a heat loss of 3.01
Oh, wow.
kilowatts.
3.01.
3.01. We're at 3 kilowatts. They literally don't make heat pumps this small. The unit out there was
11 kilowatts.
11 kilowatts.
So this is what? Quick maths. It's almost 4 times oversized.
It's like driving a Arctic truck to the shops to get some a newspaper and some milk.
What is the scope on this property?
So right now, when I moved in, it was around 2.2.
Okay.
So I started like introducing weather compensation and
They didn't have on
Or
weather
it wasn't
compensation.
turned on when you moved in?
No, I don't think so. I think it was like the settings was all over the place, and I kind of started configuring. I was like, why do we need 45 degrees flow? Like, there doesn't make sense.
So manufacturers, specifiers, installers, developer, they weren't able to help you at all.
I mean, they did try. They did some remedial work. They moved like the pump from the manifold to the flow. There was also like initially 2 returns were actually combined in one. Like it was almost impossible to get the underflow heating even warm.
We've been discussing about you having issues with efficiency of the system, horrible scope of 2, oversized unit, grossly oversized unit. A lot of people trying to help you.
Yeah.
Has any one of them at any stage mentioned the actual heat loss of the property or provided with you a heat loss calculation?
No, it was like, it started with like, let me explain you how you control. It's probably just don't turn it on properly. And when it's obvious it isn't, then it was like, no, but actually we've commissioned this system. There is a certificate, it's commissioned and it's running. But it's almost like, how can people learn from my experience? What can they ask for?
Every installation should come with this handover pack, which should say it should give the renewable consumer code that installation company should be part of, and they have to adhere to those codes during the installation. You can approach those, and there is sometimes some recourse there. However, if you follow through people that have gone through that process, they just end up going on a loop for years and years, and they give up.
Nothing happens. Basically, you end up paying yourself to having it fixed.
Yeah, there's nothing about
So we know the system's not great. We know the heat loss has never been done. We know the unit is grossly oversized. But that's just the beginning, right? You've got another information for us that's way, way bigger, right? You're not the only one.
Yeah, exactly. So the development is actually, there are 21 houses. Beautiful, small development, amazing neighbors, and we all have the same issues.
Leon just told me that he's got 4 thermostats on the ground floor, and it's open plan, right?
Yes, correct.
So it should be one zone. There shouldn't be 4 thermostats. You don't want to be turning half of the kitchen trying to fire the heat pump. An 8.5 unit in the end of Tara's house that I would quickly guess estimate heat loss at 2.5 kilowatts on this one. So you want to give that heat pump as much open zone in the house as you can.
Okay.
Turn everything on.
Okay. Yeah.
That should improve your efficiency.
So you're saying this is like too big for this house?
They all are. Every single one on this development is, yeah.
Interesting.
It's a terraced house, right?
It is indeed.
How many
yes.
bedrooms?
3.
So the smallest one on the development,
It
I
is,
would
yes.
imagine, yeah. And you also have Ecodan heat pump.
We do.
And how is it performing?
It's performing okay, but I think it can do much better.
What are you getting now? What kind of efficiencies are you getting on your unit now?
I think at the moment is like around 2.7 maximum, but at least the manuals from the manufacturer recommends that it should be around 3.5.
We've got pump for radiators, pump for underfloor heating, separation, and a pump for external unit. One circulator can easily run the system on its own. So you are overzoned, you've got too many thermostats, and that unit is already oversized even if the house is fully open. If you try to zone it down, you make it that much harder for the unit to operate. It can't modulate low enough, let's say if only the ground floor is open or only half of the house is open. And that unit will start cycling like crazy. And that cycling kills all the efficiency.
Okay.
So there are some easy wins here. Removing thermostats or keeping them on the wall, but disconnecting them, not allowing them to fire a heat pump, not allowing them to close the actuators, so maybe even removing actuators. Removing those 2 circulators that circulate water to radiators and underfloor heating separately, and just using one circulator for the whole house.
Okay.
That will improve the system in a big, big way.
So why it hasn't been done that way in the first place? I mean, what you're saying sounds very simple, right?
It is simple, yes. So what we propose is much simpler to what they installed and cheaper to do if you do it.
Exactly,
Yeah.
right? That's the first
Yes.
thing that crossed my mind. Like if you simplify, obviously it's going to be cheaper, right?
Yes, of course, yeah. Not if you have to do it again, obviously, because you have to put labor into removing those things and repiping it. But yes, that's how it should be done. Cheers to better systems. What do you want to tell to the specifiers of those systems? Because I don't want to be harsh on them either. I hope they've watched you guys know you've designed this system, and I want you to do better next time.
We know the designers of the system. We've seen plenty of work from them in the past, and it's always been basically the same. They have a set up business structure which produces results like we've seen. All I would suggest is there's training out there. Please go and take the training and change your processes that you've probably done very well on so far.
No, please, guys, please, you can do better. On that positive note, thanks for watching.